Okay, our company overview. Vail Resorts is the world's largest ski resort company and it's based out of Colorado. They own and operate a ton of resorts across North America, Europe, and Australia. They don't just specialize in skiing, they also make money from hotels, food, rentals, and basically the whole mountain experience. One of their biggest attributes is owning the Epic Pass, which allows people to ski at multiple resorts with just one pass, and so it's really convenient and keeps people coming back. What's interesting about Vail is that they're more of a travel and lifestyle company rather than just a ski company. Because of that, their revenue depends on a lot of different things, not just how many people show up to ski, but also how much they spend and how much time they spend once they're there. Their problem is specifically that demand is hard to predict. It depends a lot on weather, which is obviously generally unpredictable from season to season. If there's not a lot of snow or it's too warm, people won't want to go and won't want to visit. If conditions are really good, you can have the opposite problem, which is overcrowding. Pricing also plays a really big role. If they don't price things right, especially with the Epic Pass, it can either hurt revenue or bring in too many people at once. Recently, in the past, I would say 6 years, they've gotten a lot of backlash online about pricing and crowds, which can impact how people feel about going. Overall, small mistakes that in forecasting demand can lead to lost revenue or a bad customer experience. That's why getting this right and fixing things is such a big deal for Vail. To understand this a little bit better, we looked at a few specific data points that can help explain and understand what actually drives demand at these resorts. Oops. First, we looked at the number of runs per ski resort, which basically shows how big each mountain is and what capacity they can hold guests at. Bigger resorts can handle more people, so that affects both demand and how the crowds feel. Then we looked at the coldest ski resorts because temperature really impacts snow quality. Colder resorts usually have more reliable conditions, which makes them more appealing, especially if it's a bad snow year overall in the world. Finally, we looked at the relationship between this resort's ranking and its annual snowfall. This helps to see if the best ranked resorts are actually getting more snow or if things like branding and amenities matter more. All of this together shows why forecasting demand for Vail is so complicated and why using data like this is really important for making better decisions.
Going on to the success metrics, to value success, we first focused on a few key metrics. First and most importantly, identifying the most important variables that drive demand. So whether that be snowfall, whether that be amenities, whether that be like location, like in country of origin. We looked at all those in different models, and we tried to find which factors provided the most success to the ski resort. We also looked at whether some factors are actually important or whether some things just don't matter as much. For example, in the lab, we have a few models when it comes to just pure location. There's a lot of snowfall, and as you can see later in our graph, some places have a lot more snowfall than others for not much difference in rank, which would show that there's a lot of other factors other than snowfall that are key factors. Next slide. In our data sources, we use three main data sets. We use the ski resorts and waffle cabin locations to try to find like which ski resorts have a lot of like Airbnbs and like living locations that people can come and rent for their stay, whether that be a driver in traffic and like guest traffic in this resort. We also just use general global ski resort ranking data set, which just ranks all the ski resorts in the world. We mainly focus on the top 10. Although I think in our Waffle Cabin we expanded that search to the top 100. And then we also use the global weather repository to find our snowfall and our average temperatures, whether it be too hot or too cold. It also shows metrics like wind, the variation in the wind, or if it's just like if it's always windy, or if it's just like random gusts. These matter because these show us whether or not just the weather and locations are more important, or if it's other things like amenities, or how they handle their lift tickets and their pricing, parking, or etc. mostly just due to weather. Next slide. When we started our data collection, we used around 100 to 1,000 entries to avoid overloading our graphs and our models. This just made it easier to read and easier to handle in the coding side itself. We didn't really merge them, so we didn't have to worry too much about cleaning the data sets. Rather, we just used graphs to compare them similarly. Our graphs measure our snowfall. They also measure how many runs certain resorts have in the top 10. And then we also have just general ranking of the ski resorts.
Moving on to exploratory data analysis. These are just some of the smaller, not models, but graphs and charts that we looked at in order to get an idea of how each ski resort related and compared to others. Right here you see a scatter plot of the ranking of ski resorts for annual snowfall, and you'll see that most fall around between 400 to 600 centimeters a year, with some of the outliers being 1,200 plus a year. This is important because we would use the ski resorts in this particular range of 400 to 600 to get a good general and average idea of how demand fluctuates or changes with these particular traits that both Liv and Caden have brought up: snowfall, capacity, and ski resort amenities. Next slide. For our model usage, we mainly focused on trait metrics such as weather and resort amenities, and then ran those through predictive models in order to find correlations in demand. Like Caden said, as to not overload our data, we cut it off at 100 observations for our sample. This allows for a tighter model and avoids overfitting, and it helps with overall visual understanding when we're presenting this to the actual Vail resorts. We then focus primarily on the highest ranked resorts as well to narrow that field of where we're actually looking at. It also just sort of standardizes our data sets. Next slide. And then for our final findings, what we found to be the key variables that made the most impact were snowfall and weather conditions. In our models, those were the top predictors. Other things like amenities and capacity mattered, but they didn't necessarily have a positive correlation or higher R2 in relation to demand. Overall, we noticed a change in demand. Go ahead.
Next slide. Based on those findings, we developed a few key recommendations for Vail resorts. First, we suggest adjusting pricing dynamically based on weather forecasts. If conditions are expected to be great, then we can increase the pricing slightly, while poor conditions may require incentives to maintain demand. Second, investing in snowmaking technology will be critical, since weather is such a strong driver for demand. Controlling snow conditions can reduce the risk and stabilize revenue. Third, we recommend focusing on improving customer perception, especially around pricing. The company's faced a lot of backlash for extreme price gouging in the past. By doing that, we can reduce backlash and maintain loyalty to the brand. Lastly, using demand forecasting models to improve staffing and operations will be able to help the company run more efficiently and reduce costs. Next slide. Wrapping everything up, our analysis shows that demand is primarily driven by weather, pricing, and resort features. By applying data analysis and machine learning, companies like Vail Resorts can significantly improve their forecasting accuracy. Ultimately, making data-driven decisions leads to better revenue outcomes and a stronger customer experience, which is the main goal of this project. Thank you.